So we have used, we're doing notes on 2.8. It's the second to last notes for Unit 2. It's called wrapper classes. So I want to remind you, we have primitive variable types. The ones we've used are int, double, and boolean. There are others, but those are the ones we've used. And then we have reference or object variable, or even class variable types. And we've done strings. And let's be honest, we've done book, frog, student, all those other things we did on other days that were not built-in things. Some are custom, some are built-in. The ones, you only have to write down strings right now, but I wanted you to know we've used other types. Some things in Java require that the data you're working with be a reference or class variable type. And because of that, Java has implemented something called these wrapper classes. And the two that we're going to talk about, and they could be on the AP test, they have been in recent years, that is integer, notice it has a capital I, and double with a capital D. And it's still just a number that you can do math with. It just has other properties. So what you do if you have to make one of these integer with a capital I things, you say integer, integer x equals new integer. So this should look familiar to you. This is like creating any object, like creating a scanner, or when we were creating the frog or the book or the student, you had to say frog, Frankie equals new frog. Well, that's what you do here too. You just have to have a capital I. And then it's almost kind of like a why bother, because then you can just use x like it was a number. It's not a big deal. But what happens is these capital I integers have they have methods, and they are a reference variable type, which will matter later. And I don't want to spend a lot of time worrying about it right now. You can convert. You can say int y equals x. You can also say int z equals x dot. There's a method called int value that explicitly converts it into a regular integer. Let's print these things out. I'll copy the code over to my compiler in a second. We'll make sure this all works fine. So I'll hop back. I want to verify, since you're all writing it down, we want to make sure it's going to work fine. It ought to. Yeah. So this code works fine. Part of me resists this int value thing. It's part of the AP possible testing scope, so we have to talk about it. We'll deal with this more in a couple of months when we have the tools that make it so we have to do this. But the bottom line is there's just a more complicated integer variable type, which is capital I integer. You don't want to use this one unless you need to. And you can automatically just put it into a regular integer. You can use it in regular math, or you can use this int value. That means give me the regular plain old vanilla int value out of this object, and we store it in a variable. So the same thing happens with a double. I'll show you in a little bit. This is all, there's something called the AP Java quick reference that I'll show you today when we're done with the notes, and you'll see that we've covered a whole bunch of the stuff that's going to be on the test already. So I'm going to show you the other thing that we get from this integer class. We've already seen it. We just didn't know what we were looking at. We have integer dot max value. Remember these? And integer min value. These come from this capital I integer class, and we used them way back before without really explaining what they were. But if we print that max value, it's handy because it allows us to print the big number or access the big number without actually having to memorize it. I forget what it is. It's 2 billion something, or so that's thousands. Yeah, 2,147,000,000. That's the biggest integer you can have. Remember, if you add 1 to that, then it rolls over to the smallest integer. But anyway, these come from this wrapper class. Basically, it takes a little plain old ordinary number and wraps it up in a package that makes the rest of Java think it's an object. But we know it's still a number. And let's not make it more complicated than that. So we'll do a little practice on this today, and it's not going to be a big part of your quiz. Everything's going to be fine. It'll make more sense later. So that's it for that. We're going to end those notes. And if you were on paper, I'd say draw a line and let's do our last notes for Unit 2. And if you're electronically, hit enter twice and then write this. We're going to use the math class. All right, so the math class contains only static methods. That means we can call them without creating a math object. So we'll never say math m equals new math the way we say scanner, scan equals new scanner. You never create a math object, but we can use all the math things that we want. It's built in, available in all programs. You know, we've already been using math.random. So math.random. I'm not going to cover it again, but it's in your notes. So I'm going to write it. It returns a double. And then we have int math.abs. That returns the absolute value of whatever number you send over. And then we have a double version of absolute value. It's an overloaded method. Works the same way. Just if you send a double over, it knows that it's going to send a double back. And if you send an integer over, you get an integer back. You guys remember absolute value is just whatever the number is without the minus sign. I mean, it's really the distance from 0. But But if it's positive, it is the number, and if it's negative, it's the opposite of the number. But hopefully you guys know that. Absolute value takes whatever's in there and makes it positive. I know I'm just ripping through this, but it's just, this is math. Here's another one. We have 2 more, and then we're done. Double math.pow. And this is double base, double exponent. I'll give examples. So this this is a powerful one because you can raise any number to any other number, and whether it's 2 to the 5th power or really weird decimals. Thank you. And the last one that you got to know for the test is even easier, SQRT. Just returns the square root. That's a double. Alrighty. We'll do some examples in a second. I'll come back to this in a sec. So I want to show you. Let's do math.abs negative 13, Friday the 13th. We should get positive 13. Do you know the bad luck day in Argentina is Tuesday the 7th? No, you never have an important thing happen on Martes 7. That would just be bad. That's crazy talk. Why would you announce your new product on Martes 7? That's just nuts. I'm going to do math absolute value of a decimal, of a double. See, that works just as we would hope. And let's do pow, not power. They could have called it power, huh? What's 2 to the 5th, anybody? 32. Nice. But notice it's 32.0 because it's a double. Here's an interesting one. If you, in case you ever want to, if you can't remember square root, you can always raise something to the 1/2 power or 0.5 power, and that's like taking the square root of it, like exactly like it. So we'll get the square root of 4 is 2.0, because I raised 4 to the 0.5 power. And what do we got left? Just square root. Oh, I was going to raise 4 to the 3rd power. That's 64. And then let's do SQRT. And 400 should give us 20.0. Yeah, it all worked. So, yes, Ella. Excellent question. I tried it. And you get an interesting response. It's NaN, which in my experience means not a number. I don't know if it has a more technical description, but it's kind of like, yeah, I'm not going to do that. If it was a possibility, you could make sure your code would work by putting this inside an absolute value, or checking that it was positive before you did the square root. Yeah, I kind of wish it would have gone imaginary for us, but it didn't do it. All right, so then back to this list, just in case anybody was not done writing it down. I can make them a tiny bit smaller so they'll all show at the same time. Any questions on the notes before we jump to the next thing?